So there are two ways that this comment is true. One is pi to the pi to the pi to the pi certainly is an enormously large number, a much larger number than we could ever directly compute to check some property of. For example, if we take the engineer's shortcut and just say pi is roughly 3, the way we're supposed to compute a power tower is from the right down. So 3 to the third is 27, 3 to the 27th is 7.6-ish trillion, and then 3 to the 7.6-ish trillion is a number with something like 3.6 trillion digits. So on one level, yeah, we're not going to directly observe any particular properties of this power tower of pi's. Even more generally, though, it is surprising that there's so little we can say when we raise irrational numbers to irrational powers. It's tempting to think, well, of course pi to the pi to the pi whatever can't possibly be an integer or rational or anything like that. Surely an irrational number raised to another irrational number is going to be irrational. But there's actually a very clever way to demonstrate that that's not true. Consider something like the square root of 2 raised to the square root of 2 power. There are two possibilities right now. Either this number, whatever it is rational, or it's irrational. If this number is rational, we're done. We just demonstrated that an irrational number raised to an irrational exponent can nevertheless be rational. Now, I'm sure that feels like I'm cheating. I haven't done anything yet, right? What if it's not rational? Absolutely. Let's think about it. If root 2 to the root 2 is definitely irrational, we're going to adjust. We're now going to consider a second statement. Let's take this root 2 to the root 2, and this time, let's raise that whole expression to the square root of 2 power. Now, first of all, we're in case 2 right now, so we're assuming that this root 2 to the root 2 is irrational. And of course, we also know that root 2 itself is irrational. But there's a particular property of exponents that says when we raise a power to a power, we're supposed to multiply those exponents. So root 2 to the root 2 raised to the root 2 is actually the same thing as root 2 to the root 2 times root 2 exponent, which is 2. And furthermore, root 2 squared is also simply 2. And so what this means is we've just shown that even if root 2 to the root 2 is irrational, when we raise that to the root 2 power, we get back a rational number. Now, to be clear, this does not mean that we should expect pi to the pi or some power tower of pi's to be rational and certainly not to be an integer, but it does show us that it's impossible to assume it's not going to be those things just on the basis of pi being a transcendental number.